Jérôme, everyone, has been waiting patiently, is here to speak to you. Give him a warm round of applause. I will make my exit.
Hi, everyone. Good afternoon. First, I have to say that it's pretty exciting to have the little ads before, because it's a little bit like going to the movies to see a blockbuster. And so before you watch a movie, you have these little ads. If it means that I'm going to be the next Marvel or DC blockbuster, I guess I'll take it. Anyway, so I'm Jérôme Petazzoni. You can find me on Twitter at jpetazzo. I worked for 7 years at Docker, which is probably way too long. And I did a lot of things on containers here. And that's actually my second time at Craft. I was here in 2016, which was about 23 years ago, I think. And back then, I was struggling with burnout and depression. And there is this thing called anhedonia, which means that you can't feel joy and pleasure, basically. And I can definitely see a difference, because now this is my second time in Budapest, and I'm enjoying it way more. I'm noticing way more like the architecture and many things. So I'm happy to report that I'm going much better, and that I'm in a much better state to enjoy Budapest and the conference. Also, since it's been a really long time that I haven't been on a conference stage, I'm going to do a little conference selfie. So if you don't want to be on the picture, just hide your face. But there we go. And let's get started. So why this talk? Since I left Docker in 2018, I've done lots of consulting and training on containers, Docker, Kubernetes, and I was already doing that before anyway. So I spent a lot of time with students and customers and friends, helping them to solve various container issues. And I've seen a lot of, let's say, not so great stuff. So I decided to make a list of the not so great stuff, but also my tips to refactor them and make our work with containers more enjoyable. There are probably many things that I'm going to tell you that will seem maybe obvious, and if you are on that camp, then that's great. But there are also many tips that, if you haven't met that problem before, or if you have had that issue, I hope that what I'm going to tell you will help you, basically. Also, if you prefer, a slower pace, or if you enjoy reading, I've wrote a blog post with most of these talking points. If you scan that QR code in the corner, that's going to take you to the slides, and then you can click on all the links, and the QR code is going to be visible on every slide, so that's great. So in this talk, I'm going to go for breadth instead of depth, which means I'm going to try to talk about many different things, but maybe not go as deep as I would usually go when I talk about container things. If there is one thing in particular that you would like to know more about, feel free to talk to me at the end of the talk, or even later, ping me on Twitter or whatever. You can't see my Twitter handle because it's in that little corner, and I probably messed up my screen configuration here, but if you go to the slides, there is my Twitter handle in the corner as well. Another thing is that I tend to put a lot of things on my slides because, as you can probably guess from my accent, I'm not a native English speaker. I'm also not a very good English listener, and when I started to attend English talks, I often had lots of difficulties to understand what the speaker was saying. Not the fault of the speaker, like mine. So I decided when I started to give talks that yes, I would put lots of text on my slides, and some folks say, no, you shouldn't do that, you should just have nice pictures and inspirational things. And I'm like, no, I want folks to understand what I'm talking about, and if there is something where I speak too fast or my accent is too thick or whatever, I'm happy if you can find the information on the slides instead. Now, a lot of the things that I'm going to say in this talk should be taken with a grain of salt, in the sense that when I'm going to tell you, you should not do X, it means generally doing X is not so great and maybe you should avoid it, but of course there are always exceptions, so don't take this as absolute rules, more like guidelines. And a big important rule for me when working with containers I don't work with containers just because. I work with containers because it saves me time or money, or it makes my deployment more reliable. That's the goal of containers. We do containers to improve the way we ship software, not to tick some checkbox and say, yay, we do DevOps. So if there is something in that talk, that you try it and it doesn't work for you and it makes things worse, then roll back and don't use that thing and it's fine. Now, some of the patterns that I'm going to talk about compound. One example, one general rule could be try to have smaller images. Another one is try to not push and pull your images all the time. And of course, they compound. If you push and pull images all the time, but the images are small, that's fine. If you have huge images, but you never push and pull them, that's fine as well. It's when you mix both that things get really bad. So that's what I'm going to talk about. When images are too big, then when images are too small, you might wonder, wait, can we have too small of an image? Yes, I'm going to talk about it. Then we're going to talk about problems when the builds are too long and when they are too complicated. All right, so what should I do when my image is too big, or what could cause my image to be too big? First, what does it mean, too big? It means that I'm going to ask questions with these numbers here. For instance, if you have a microservice and it's more than 100 megabytes, I'm going to start asking questions. It doesn't mean that it's bad. It means that I'm going to investigate. Is there a good reason for that? Maybe we have lots of dependencies, or maybe I don't know. But I'm going to start asking questions because maybe that's where there can be some interesting savings. And for monolith, I would set the bar at about 1 gigabyte. So this is when I'm going to start to see if we could optimize things. So the first thing that we probably should do to optimize image size is multi-stage builds, because this is going to be the thing that will yield the biggest results. Out of curiosity, who here is already using multi-stage builds in their builds? So a few folks. And who is not or has never heard about multi-stage builds? Less hands. Okay, so many folks are already using multi-stage builds, so I'm not going to spend too much time on that. If you want to learn more about multi-stage builds, again, I've wrote a ton about that topic. I have not one, not two, but 3 blog posts about small images and multi-stage builds. And just to give you some numbers, if I take a look at this, you can see that in some scenarios, for instance, this C program, we go from a 1 gigabyte image to 70 megabyte image by using multi-stage, and then 5 megabytes if we also switch to Alpine. So that's pretty nice. Same thing with Go. We go from 1 gigabyte to 80 megabytes, and then 7 megabytes if we keep optimizing. The savings are a little bit less impressive if we go with Java or Python, but still, like Java, we go from 600 megs to 50 megs here. That's the kind of savings that we are talking about. So that's one thing that, if you're not using multi-stage builds yet and you want to reduce the size of your images, that's a low-hanging fruit. Another thing is that we should avoid to include data sets in images. So here, I'm not talking about a 1 meg or 5 megs data set, but more something like 50 meg, 100 meg, a few gigs. So if you have, for instance, a machine learning model or some reference genome data or something like that, why should we not put that in images? Because this is going to torture our container registry. The containers registries are not optimized for speed. I mean, they kind of are, because people writing registries and running registries try to make them as fast as possible. But at the core, it's just like HTTP pools. There is no multi-part parallel, etc. So it's not made for speed. So it's better to leave the models outside of the image and then download the models using something that's really fast. If you store the model on S3 on some other object store, you will be able to use parallel transfers and things like that, and it will be considerably faster. And it's going to also save you tons of disk space, because if you put your model in your image, each time you rebuild a new version of the application, you end up with a new image, and if you are not careful, you end up with a lot of disk space usage and then garbage collection problems, disk space usage on the registry, but also on your nodes, etc., etc. Solutions, when working locally, you can use a bind mount. So basically, you agree on the location where you want your data to be, let's say /data, and then we do a command like this to say, get the data set that I have locally, mount that in the container, and that's it. If you're using Compose, you can put that in the Compose file, and that's completely transparent, and you end up with much smaller images. If you are on Kubernetes, and so I don't know how many folks here work with Kubernetes. Just quick show of hands. Who's working with Kubernetes? Many. And who's not? Less hands, but still a few. OK. So on the left-hand side, I have some YAML. I'm not going to analyze it line by line, because that would be very boring. But basically, this shows how to use an init container. So the idea is that if I have, let's say, a worker container that works on a data set, I'm going to have a separate init container just to download that data set, put that in my /data directory, and that way I can cleanly separate things. You know, if I'm using, I don't know, the AWS CLI or curl or BitTorrent or whatever to download my data set, I can leave that outside of my worker so I can have simpler images. All right. Now there is some optimizations that you can do around that if you work with that kind of data set. If you have multiple workloads that use the same data set, you can download that data set on a volume, like on a directory on your nodes, so that you only download it once, even if you have many workloads. And you can even preload these data sets by using a daemon set in Kubernetes, so that each time a node joins the cluster, you automatically download your data set and your workloads can start faster. Another one, avoid these huge, like Swiss Army knife style of images. You know that image where you have Python and Ruby and Node, and in fact we have Python 3 and Python 2 and tons of tools, etc., because who knows, maybe we might need that someday. These, I think, are bad, or maybe I should say not so great, for a couple of reasons. First, these images can be big, sometimes so big that you get timeouts when you try to pull them. So you start having some really weird issues because images are too big. Plus, if you have hundreds of packages in your images, you have two solutions. Either you don't update the image, and then in about 5 minutes, you're going to have vulnerabilities and that kind of problem. Or you update them all the time, which is great, but now you have another problem around repeatability. If you have a problem with a version of the image, the version of May 27th, then if you want to reproduce the problem, you need to have that exact version of the image. So you need to know which version you were using, and you need to make sure that you still have that image on your registry, which means that your registry is now going to be huge. So problem. Okay, how do we fix or work around that? First thing, if instead of pre-installing everything in the containers, we can install things when we need them. An example, if I want to use TCP dump, which is a little network analysis thing, if I'm in an Alpine container, I can do apk add TCP dump. And that's going to download and install TCP dump. And this is so fast that I think that this is faster than pulling a TCP dump image that would be based on Debian, Ubuntu, Fedora, etc. So for tools that are packaged in Alpine, I just use Alpine, and that's it. That saves me a lot of time. The second technique is to use ad hoc images with something called Nyxory. Out of curiosity, who among you already knows about Nyxory? A few hands, yeah, that's almost more than what I was expecting. Nyxory, so for everyone else, good news, you're going to learn about a really cool tool when working with Docker and Kubernetes. Nyxory can build custom images on the fly. So for instance, if I want an image with a shell and also that TCP dump that I was talking about, I do docker run nyxory.dev/cell/tcp dump, and it's going to, on the fly, generate an image with these packages installed. Usually when I do that demo, I do like /cell/helm/kubectl/terraform/ffmpeg, and it works. It generates an image with all these tools. I'm not going to do that here because I don't want to kill the Wi-Fi just by pulling a 300 megs image, but you can see, there we go. I have an image with that pre-installed. You can do like TCP dump, and that works. So Nyxory, super useful. We're going to talk about it again in a few minutes because it has other really interesting use cases. It's based on Nyx and NyxOS, which are respectively a functional package manager and a distro using that. Anyway, really cool stuff. Now there is at the other end of the spectrum when my image is too small. And like, okay, how can I have an image that is too small? What's wrong with that? Well, what's wrong with that is that very often, if you have a really small image, it means that you used one of these things like from scratch or distroless or Docker Slim. And so at first it's great because you have these tiny images, and then when you need to troubleshoot these images, that's when the pain starts, because you're like, okay, let's use Docker Exec or kubectl exec to get a shell and look at what's going on, and you don't even have a shell, so you can't do that. So there is a first solution, which is, this is inspired from a Soviet-era joke that I was told when I was younger, which is supposedly like this person goes somewhere like in the Soviet Union and goes to some kind of, stays with someone, and the person tells them, if you need anything, come to me and I will tell you how to do without it. And so here is the same idea. It's like, well, you don't really need to get a shell in your container. If you need to get a shell, come to me and I will tell you how to do the same thing without getting a shell. So for instance, if you want to look at your logs, well, you should not put log files in the container. You should log on std out, and then you can use Docker logs, kubectl logs, have a log concentrator. That works great. If you want to look at the memory or disk usage or what processes are doing in the container, you can do that from outside the container with stuff like Docker top, Docker stats. We have similar tools with Kubernetes. Install something like Prometheus or Datadog to get metrics, etc., etc. Unfortunately, sometimes you really need to have a shell in the container. If you have some permission issues, you know, like if you are on AWS and you have some IAM role problem, usually one of the first things we do is AWS STS get caller identity, which tells us what identity we have from the perspective of AWS, but that requires that you have the AWS CLI in the container. So that's a pretty big dependency. Another thing is when troubleshooting like network connectivity issues, or we were talking about data sets. I want to check what's the data set in my container, so I would like to have these tools anyway. So two solutions here. The first one, which is my personal favorite, is to say, okay, it's great to try and have small images, but let's not try too hard. So instead of using from scratch, let's put from Alpine or from, you know, some really small image so that we at least have some tools so that we can look at what's going on. Now, some folks will answer to that like, well, now you have you have a bigger security issue, you have a bigger security footprint. One of the goals of from scratch and distroless is to reduce the number of packages. So if we use Alpine as a base, we defeat that. Okay, fine. If you really want to have these small images, I have another kind of tip or hack for you. which is, again, using that Nyxory thing. The idea is to use Nyx to embed the tooling in a volume. Okay, so to quickly explain what this is about, normally when we run something, a program on a Linux system, this is going to be a dynamic program that depends on some system libraries. And so I can inspect which libraries it's using, like this. So you can see in that case that it's using a bunch of libraries in /user/lib/lib64. Okay, now let's compare with the same scenario in Nyx. I need a file, I think. There we go. So in Nyx, my shell is a symbolic link to something in /nyx/store. And if I look at that, it's a dynamic program. But that dynamic program depends on libraries that are themselves in /nyx/store. So long story short, if I'm using Nyx, all the stuff that I need is in /nyx/store, which means that what I can do in Kubernetes is something like this. I do apologize for the salad of YAML here, but the idea is that in my application container here, I'm going to have a volume on /nyx, and in that volume, I'm going to put all my tools, and to get the tools, I'm going to have an init container using any Nyxory image I want, and copying all the stuff in /nyx to that /nyx volume. So what I'm doing here, it's a little bit like a little platform with all the tools that we need, and we bring that platform in the application container so that we can do whatever we need to do without overwriting or replacing the files in the container. Of course, this means that you need to restart that container, well, create a new pod with the volume, but at least you don't need to rebuild an image to get your tools in the container. All right. Another thing that I've seen too many times is folks who compress things before putting it in the image. Like you have this, again, a data set or a bunch of fixtures or SQL files, etc. And then I think, I'm going to save some time and some disk space by compressing that in my container image. Unfortunately, that doesn't save anything. Quite the opposite, because first, Docker is going to compress the images really well, so there is very little chance that your compression is going to save even more. If you compress a file that's already compressed, it doesn't help. So compressing doesn't help. And the second thing is that if you put some compressed data in the image, then you need to decompress that data at some point, for instance, when the container starts. So now when the container starts, instead of starting instantly, it will need to uncompress the data, which could take a few seconds or a few minutes if we're talking about lots of data. That could also use lots of CPU if you use one of these super efficient, super packed compressing algorithms. So that's not really helping in any way. So you don't need to compress things when you put them in container images. All right. So now that we talked about the size of the images, let's talk about a few anti-patterns about the build in general. A very common issue, build is too long, build takes forever. What are the anti-patterns and problems that could be associated with that? A very common one, let's say that you do some data science and you have, let's say, 3 applications, A, B, and C, and they all use a base image, like a custom base image with, I don't know, NumPy and a bunch of other data science stuff, like all your in-house libraries, etc., etc. So if you do that, that's perfectly fine, but then my suggestion is make sure that this base image is on your registry. Don't force your data scientists to rebuild it each time, because this is going to take a lot of time, because typically these base images tend to be pretty big and tend to take a lot of time to build, and so basically you're going to waste a lot of data scientist time by forcing them to rebuild that. Now, sometimes the counter argument is, well, we do that because we want to make it easy to tweak that base image. So that's why we have people rebuild it, because very often they need to change something here, so we want them to have the Docker file. Okay, fine. If you want to do that, there is a little trick that you can do with Docker Compose. You can specify both a build and an image tag for a service. And again, I have an example like linked from the slides where I'm going to have my data science images that are going to do something like this, like from my base image. So this is my expensive, big base image. And then in this other directory, I have my foundation image. And here, the trick is that I have both build and image. So that means I want to build that Docker file, but I want to use a specific name. So now my workflow is, if I want to work on one of these applications, I just go to the application directory, I build, it's going to pull the image from the registry, everything is great and fast, awesome. Now if I want to tweak my base image, I just go to that foundation directory, tweak the Docker file, Docker Compose build, and then go back to the other application and build again. So that saves, it may not seem like it, but that really saves a lot of time. Another one is if you have one of these big monorepos with tons of files in it, maybe that monorepo is a mess, I don't know and I don't judge, but when you do a Docker build, the first thing that Docker does is upload the entire build context, so the directory where you have your Docker file, to the Docker engine. And even if your Docker file is perfect and uses caching and all that stuff, before the build starts, you have to upload that stuff. So if you have that huge repo, you upload like 5 gigs for nothing. So what's the fix here? So you could use Docker ignore. With Docker ignore, you can eliminate some parts and not send them to the Docker engine. You could also, and I think that's the simplest option, enable BuildKit. Because when you enable BuildKit, it will do something a little bit magic. When you do a Docker build, instead of uploading everything to the Docker engine, it's going to upload things only when you need them. So if you do a copy, blah, 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 then it's going to copy the blah, blah, blah. But as long as you don't copy anything, it doesn't need to push anything to the Docker engine. And even when you copy blah, 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 it's able to do a kind of, I don't know, let's say client-side diff or checking, so that if you haven't changed that file, it's not going to send it to the Docker engine. So we're basically talking about an extra layer of caching on top of the normal Docker caching that you might know. BuildKit is enabled by default on recent versions of Docker Desktop. So if you are on Mac and Windows, you don't have anything special to do. But if you are on Linux, you have to set that environment variable to turn on BuildKit. And since most of our build pipelines are on Linux, they may not always use BuildKit, so it's always a good idea to have a look at that. Another thing, and that one, I think that most folks working with Docker know that, but I was myself surprised to see, like, year after year, so many folks starting with Docker and not doing that optimization. We don't need to rebuild every single time. That's kind of what we learned in the beginning. You know, I change a line of code, Docker build, Docker run, and I iterate like that. Change a line of code, Docker build, Docker run, and since I have a really nice and optimized Docker file, the build takes 3 seconds, so that's okay. But even 3 seconds is too long, especially when it's not 3 seconds, but 3 minutes or 3 hours. Instead, we can mount the code of the application to the container so that I make changes, save, hit reload or whatever, and I can see my results in real time. That works great with interpreted languages. What about compiled languages? Because if I make changes to my Java or Go code, obviously to run it in the container, I need to compile that code first. So here, 2 methods. If you work with a language that has excellent support for cross-compilation, like Go, for instance, then you can build locally and then you get the binary in a volume. At first, this might seem counterintuitive, like, wait, I thought that with containers, we should build everything in the containers to have like perfect independence between the host and the container. Yes, but here, if we're talking about taking a shortcut in the dev cycle, yes, in that case, we can break the rules a little bit. Another method is to build in a separate container. So I have my application container, which is happily running. And when I need to update that Go binary, Go, Rust, or Java jar file, I have a container on the side that's going to do the build and drop the binary or the jar file in the first container. One example of that, pushed kind of to the extreme, is in that excellent talk from vCorbs where they show how long it takes when I'm working on Go code and when I save my source code, it's going to build the code and deploy it to a Kubernetes cluster. And so the question is, how fast can it be? How long between I save the code and it's available in the Kubernetes cluster? And if I remember well, the answer is less than 5 seconds. Of course, you need to optimize quite a bunch of things, but that gives you an idea of what you can achieve. Compare that with what I've seen so many teams, like when they want to add a print somewhere in the code because they don't have proper logs, they add the print and then you need to commit and push and then you wait like 15 minutes for the CI to do the whole thing and deploy it to staging, and then maybe after 20 or 30 minutes you can see the results. That might seem extreme, but I was shocked to see how many teams have that kind of workflow today, whereas if you take a little bit of time to set up the right build environment, it's not 20 minutes, it's literally 20 seconds. So that's, I think it's pretty important. So speaking of taking the time to set up like the perfect build process, here are some things that I've seen in the build process, which I think, again, not so great. So very often, we have a build process that's getting a little bit more complicated, right? So you end up with, I don't know, 10, 15 run lines, and at the end you're like, okay, you know what? I'm just going to put that in a script. I'm going to add the script in the container and run it. It's all right if you really have a lot of things to do, okay, why not? But personally, I prefer to try to put things in the Docker file. Just one thing, very important, when you put multiple commands in the Docker file, use this double ampersand, which means that if there is a problem when running that command, it's going to stop immediately instead of executing the whole pipeline. If you put semicolons and there is a problem in that command, it's going to just happily run all the commands one after another, and you won't notice that you have an error until much later. On the other hand, if you have a lot of logic that repeats itself, this is an excerpt from a Docker file that I built, I wrote to build a tooling image. And by the way, this is a perfect counterexample to a thing I said earlier. Avoid like Swiss Army knife types of images with 1 billion binaries in them. This is exactly it. This is a container image with 20, 25 tools in it. So why am I doing that? Precisely because these tools are not always packaged, or I want like the latest version, or I want a specific version, or I want an all-in-one experience. Like specifically here, it's for students in my trainings. I tell them, okay, if you want all the tools that we need for the training, get that image, everything is in it. So of course, then I build that image, and you can see that helper curl that appears all over the place. This is to factor some information that I was repeating over and over. So I went from something like a 300 lines Docker file to a much shorter one, just by having that little helper, and also it's much easier to maintain. Another one very often we write a script to build our images, and in that script we're going to do some Docker run, Docker build, Docker this, Docker that, and very often this could be replaced by a compose file, and all we would have to do is Docker compose build. Not always, but very often. In particular, one thing that can really mess you up is when you use Docker Compose Exec, for instance, in a CI or test environment. Why? Because when you use Docker Compose Exec, it means that you want to execute something in a running container. Why do you want to do that? Well, two reasons. Either because you want to run a program from that container, and in that case, you could just use Docker Compose Run, or maybe that container is, let's say, a Postgres container, and you want to connect to Postgres. But if you do Docker Compose Exec, you have no guarantee at all that Postgres is actually running. So you should do things differently, because this is a perfect recipe for race conditions. Stuff that will work on one machine but not another, because on some machines the database will have the time to start but not on the other one. So that's something that, it's a code smell, as we say. When I see a Docker Compose Exec in a CI or test pipeline, I'm pretty sure that there's going to be some race condition there. Okay, so what can we do instead? Some tricks. One very useful thing is that you can merge multiple compose files. So for instance, if you have a compose file with the application and another one just for some test or CI, you can merge both compose files, and very often that reduces the complexity of the tooling that we have around it. Two last ones on compose. First, there is a pretty new feature in Compose called profiles. So you can group your services in profiles, like front-end, back-end, off, etc. And you can indicate which groups you want to start. And the last one, that's using a .env file. This is the kind of stuff where, again, if you know about it, then you're going to use it all the time. But if you don't know about it, you can't just invent it. But I've seen many folks have an env.sh file and copy that file to the container and then source that file to set a bunch of env variables, while you could directly use a .env file and simplify a lot of things. Another thing is that we should not force things to run in containers. Ideally, when I have my build process, my compile process, or whatever, I should be able to run it locally. And then, yes, if I'm using a ton of tools, maybe I want to have a container image so that I don't have to install all these tools locally. But I should still be able to run the tools locally. If I'm forcing things to run in containers, from my perspective, that's a problem. I'm also special shout out to when we have a CI job called test, because guess what? There is a POSIX tool called test as well, so this is going to cause conflicts. I know at least 2 teams who have a tool called Go, and I'm thinking the day when they start working with Golang, what are they going to do, basically? And then having tools like BC or DC. I'm guilty of the last one, because Docker, before being Docker, was a company called .cloud, and we had a container engine, and the CLI for the container engine was DC. And DC is also a standard Unix tool, not one that we use a lot, so usually it's not a big problem, but again, we should try, when possible, avoid using standard names. Another thing, avoid the complexity that we don't know how to handle, and one of my favorite examples is Bazel. Bazel is amazing, it's awesome, but it's awesome if you have hundreds of developers and you can justify having one full-time engineer just to maintain your Bazel rules. That might seem a little bit excessive, but I can guarantee that if you have the kind of complexity that justifies using Bazel, then you will need one full-time person to maintain it. And if that person left 6 months ago, you're going to have a bad time. So I'm not saying run away from Bazel. I'm saying if you want to use a tool like that, make sure that you have the resources to properly support and maintain it. You know, even the Kubernetes maintainers, who are probably amongst like the brightest and best engineers in that space that we have at the moment, decided to not use Bazel because it was too much complexity for them to handle. A couple of last things. Sometimes the Docker file is not the best solution. We have some special purpose tools. For instance, we have Go. If you only work with Go, Go is able to build like very nice, very optimized images for Go programs. And outside of that space, there is also something called build packs. So if you hate Docker files, you know, if from the very beginning, each time you have a Docker file, you start to feel rage filling you, then have a look at build packs. It's a completely different approach. You may or may not like it, but since it's very different, maybe it will work for you, who knows. So sometimes the best solution is to completely scrap the Docker file and use a different approach. All right, to wrap up, again, I repeat what I said in the beginning, but don't treat this as golden absolute rules. These are just like guidelines, ideas to try and improve our builds. And individually, most of these things are not so bad. It's more like when you combine multiple anti-patterns together that things get really, really, really bad. Again, be pragmatic. So don't apply one of these because some person on a stage told you to do so. Apply one of these if you see that it's going to save you time and make your container experience more enjoyable or at least less painful. Again, if you like to read, I do like to read, so if you like to read, I've wrote a blog post that covers more or less the same ideas. You can scan that QR code here to have the slides and all the links, and that's it. I think we only have 10 seconds for questions, which is not enough, but I'll be available here. And again, don't hesitate to ping me on Twitter later if you want. I'll be happy to talk about these topics. Thank you.
Woo! Okay, we've got time for one question. It comes from Istvan, who says, I have heard that Alpine has compatibility issues in some application programming platforms. Is 50 megabytes compared to a slim Debian, I almost read that wrong, worth the hassle?
Excellent question, and I would say that there is one scenario where you're absolutely right and we should avoid Alpine. It's when working with data science with Python, because when we install Python packages, they are going to come from PyPy, like the Python like package index, and they will be pre-compiled for GNU-libc, which means not Alpine. So it means that if you're using, let's say, a normal system, when you pip install Matplotlib or NumPy, SciPy, it's going to be super fast. And when you do it on Alpine, it's going to take 45 minutes, which is not great. So that's the perfect counterexample why we should not blindly, you know, like, oh, use Alpine. In that kind of scenario, yep, it's better to use a slim image. My personal technique is that I try, you know, like after using multi-stage and seeing the results, I'm like, hey, what would happen if I were to switch to Alpine? Give it a try, see if the savings are significant and worth it, see if I hit any bug, any problem, and make the decision based on that.
Awesome, thank you again, Jérôme. Everybody else? Yeah, clap.
Thank you.